Alright, so we're going to be looking at evaluating radicals today. Remember, radicals are really just roots, square roots, cube roots, fourth roots, stuff like that. We're going to focus really just on square roots and cube roots. Most of this you've actually seen already, so I'm not going to spend too much time focused on this, but I do want to run through some important definitions and some very basic calculations with you. Okay, so first, when we're looking at radicals, you guys probably remember that they are the reverse of an exponent. And so if 3 squared is equal to 9, then the radical that's related to that would be the square root of 9 is equal to 3. Okay, now in this radical expression, we have a couple things. First of all, we have what's called the radical sign. That's this symbol right here, is the radical sign. The number underneath the radical is called the radicand. Okay, radicand is whatever's under the radical, or in the radical. Okay, so that's called the radicand. There are also another feature that's called the index, which I don't really have written in here. Let me give you another example though before I move into that. Let's say I had 2 raised to the 3rd power. That's equal to 8, right? 2 times 2 times 2. A related radical then would be the cube root of 8 must be equal to 2. Right? So it's undoing the cube. Here the index is 3. The index is that little number that tells you what root you're taking. In the first one, the index was 2. We just don't write the 2 in for a square root. We do write the index in for every other root. Okay, so here the index 3 is the index. Okay, so these are really the 3 main definitions here we need to look at. A couple other things I do want to mention as well is that even though 3 squared equals 9, and that tells us the square root of 9 is 3, we also have another square, another number whose square is 9. However, we don't use that number, the negative 3, when we take the square root. And that is just a convenience. We're going to define this radical as what we call the principal square root. Okay, and that's going to basically be the positive one. So that radical sign is the principal square root. Basically what that means is that it's a positive number or 0. It could be 0 if we're taking the square root of 0. Okay. If you wanted the other number, the negative number, you'd have to put a negative in front. Okay, so you could do this. The negative square root of 9 is negative 3. That's what we call the negative square root. Okay, so we have the principal square root and the negative square root. Okay, cube roots, you don't need those because cube roots of positive numbers are positive, but also cube roots of negative numbers are negative. So the cube root of negative 27 is negative 3. Alright, so cube roots, you don't have to worry about what's principal and what's not, because they all the answers will always have the same sign as the radicand for a cube root. Okay, now a few things with roots before I really get into calculating them is you're going to want to know these 2 very fundamental lists of numbers. Okay, the first one are the perfect squares. And we've seen these perfect squares before when we did Pythagorean theorem, but I'm just going to run through them anyway. I'll give you a quick list. 0 squared is 0, and it's always a number whose square, or a number that's a square of another number. So 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, then you get 25, 36. I'm going to just run these out. 49. Nope, 64. I don't know what I'm writing there. 81. I was probably jumping ahead, wasn't I? 100. 121 is 11 squared. I can run down here. 144 is 12 squared. 169 is 13 squared. 196 is 14 squared. 225 is 15 squared. 256 is 16 squared. And I'm going to call that good. So these are some of your basic perfect squares. You're going to want to be able to recognize those and use them. So the square root of 196 is 14. That should be a pretty quick one for you. The square root of 81 is 9, and so forth. I also want you to be very familiar with perfect cubes. Now these are a little bit harder because they are third powers. Okay, so again, 0 cubed is 0, 1 cubed is 1. Those are the easy ones. 2 cubed is 8 because 2 times 2 times 2 is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. Now generally I would say that this is as far as you should usually need to go. However, you may see some bigger ones in the homework, so I'm going to go ahead and run a couple more out for you. 6 cubed is 216. 7 cubed is 343. And 8 cubed is 512. 9 cubed is 729. And 10 cubed would be 1000. I think we'll cut it off right there. Okay, so that's a list of your perfect squares, perfect cubes. I don't think you'll need to memorize this many perfect cubes, but I would say definitely up through 125. You may see a couple of these. What is this? The 6 squared and the 6 cubed and the 7 cubed as well on occasion.